Hi, my name is Skylar Mel, and this is Lab 1, which is the constant velocity lab. And the purpose of this lab was to construct and observe the motion of some object that was moving at the same speed without changing direction. We filmed an object moving at constant velocity, then used Tracker to analyze the video. Then we used GlowScript to develop a computational model of the object. The concepts that were addressed in this lab were Newton's first law, which states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted on by an unbalanced force. When we observe a change in an object's velocity, we say that it has interacted with something. Newton's first law of motion is exemplified with the ball roll because the ball stays in motion with the same velocity because it is not acted on by an unbalanced force. Newton's second law states that a change in momentum means there is a net force acting on the system. The momentum principle states that the change in momentum of a system is equal to the net interaction or force acting on the system by the surroundings multiplied by the duration of the interaction. Newton's second law of motion and the momentum principle are exemplified because there was no net force acting on the ball when it was rolling. Therefore, there was no change in momentum. This is a video that I took of the ball rolling. And then this is the analysis using Tracker, which shows the position versus time graph and the position versus time chart. I used GlowScript code to create the computational model, and on line 16 to 18, it creates an object of the model, and on lines 21 to 24, it creates a graph, and on line 32 is the mass of the ball. Line 35 inserts the ball at the origin. Line 36 sets the initial velocity of the object. Line 39 starts the time at 0, and line 40 is the size of each time step. Line 54 shows that the net force is assumed to be 0. Line 58 is Newton's second law and the velocity update formula. Line 60 is a position update formula, and line 68 plots the position of the graph that was made. The assumptions were that there were no net force acting on the ball, which would lead the ball to move at constant velocity. This is an observed position versus predicted position graph, and they're pretty similar. The observations were that the object was given an initial velocity and no net force, so the object moved at almost constant velocity. The observed model differed slightly from the computational model because it was difficult to select exactly the center of the ball on the track. Also, due to human error, not knowing every force acting on the ball might not be moving exactly at constant velocity. When I filmed the video, I set the positive x direction as moving to the left because the ball was rolling to the left. If I were to flip the x-axis, then the ball would have been moving in the negative x direction. When the net force was set equal to 0 in the computational model, the results were very similar to the observed model. It is impossible to say how many forces were added together to give a net force of 0 in the case that it was observed, because the measurements were taken as a whole of the system, not just one push or pull. However, we do know that the velocity was constant, therefore the net force must be 0.